Hey everyone, how you guys doing today? We're moving into chapter 3. I'm gonna try and record a bunch of these videos today. So you guys will be seeing a bunch of these for a while. But yeah, I'm definitely not abandoning the other thing because it's actually extremely important to me. Um, Even more so than the first one. Like the first one might be pseudo abandoned, wherein I'll come back to it like much later when it becomes more prevalent that I need that stuff. But right now, yeah, okay. Anyway, so going into chapter 3, which is all about functions. In the previous chapter, we used several functions provided by Python like int and float, and a few provided by the math module like square root and POW. Square root for square root, POW for raising powers, which is another way other than the exponentiation operator, which is star star. And we discussed this last week where we talked about, not last week, last episode, wherein essentially I think the reason POW is kept despite having the star star operator is because I think it wasn't there throughout the entire Python 3 lifecycle. So POW from the math module still remains to ensure backwards compatibility with other people's code. In this chapter, you will learn how to create your own functions and run them, and we'll see how one function can call another. As examples, we'll display lyrics from Monty Python songs. These silly examples demonstrate an important feature. The ability to write your own functions is the foundation of programming. This chapter also introduces a new statement, the for loop, which is used to repeat a computation. Defining new functions. I'm just going to run this. Function definition specifies the name of a new function and the sequence of statements that run when the function is called. Here's an example. Def print lyrics. Print I'm a lumberjack and I'm okay. Print I sleep all night and I work all day. So basically if I just run this function, so running this cell does nothing, and then when I run this function by calling it, I'm making a function call to this function. We run it and boom, we got the stuffs, got the fun stuffs, we got the output that we wanted, the stuff inside the function. That's what happens when you call a function. Def is a keyword that indicates that this is a function definition. The name of this function is print lyrics. Anything that's a legal variable name is also a legal function name. The empty parentheses after the name indicate that this function doesn't take any arguments. The first line of the function definition is called the header. The rest is called the body. Oh, okay, I've never heard those terms before. The header has to end with a colon and the body has to be indented. By convention, indentation is always 4 spaces. The body of this function is 2 print statements. In general, the body of a function can contain any number of statements of any kind. Defining a function which creates a function object which we can display like this. Yeah, so because I'm not calling the function here, I'm just printing the function. This is just creates a function object. When I run the cell where I define the function without calling it, right? I'm essentially defining this function. And then I have the function object. Because everything is an object in Python, right? That's like the high level meta class that everything else comes from, which we saw with why type of type is type. So yeah, it's a bit confusing. The output indicates that print lyrics is a function that takes no arguments. Main is the name of the module that contains print lyrics. Eh? What's going on over here? Show hidden output. Takes no arguments. Underscore main is the name of the module that contains. Now we've defined a function. We can call it the same way we can build in functions. So this is actually not showing us the underscore main. Okay. The output indicates that print lyrics is a function that takes no arguments. Underscore main underscore is the name of the module that contains print lyrics. Now that we've defined a function, we can call it the same way we call built-in functions. Okay, so apparently in this output, you should see the name of the module it's in, which will be underscore underscore main, because this is kind of our main. I think things get a bit fuzzy with Jupyter Notebooks and not as clear, but yeah. Parameters. Some of the functions we have seen require arguments. For example, when you call ABS, you pass a number as an argument. Some functions take more than one argument. For example, math.pow takes two, the base and the exponent. Here's the definition for a function that takes an argument, right? So this is basically you saying that I need some string, some variable that within the function we will call string, right? And print that twice. That's all this function is doing. The variable name in parentheses is a parameter. When the function is called, the value of the argument is assigned to the parameter. For example, we can call print twice like this. Print twice. Dennis Moore, Dennis Moore. Okay, there you go. Running this function has the same effect as assigning the argument to the parameter and then executing the body of the function like this. Right? So, boom. You can also use a variable as an argument, right? So line equals Dennis Moore, and then I can just pass that line in. Pretty straightforward stuff. In this example, the value of line gets assigned to the parameter string. Calling functions. Once you have defined a function, you can use it inside another function. To demonstrate, we'll write functions that print the lyrics of the Spam song. Spam, 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 lovely spam, wonderful spam, spam, spam. That's a very weird song, but whatever. So we'll start with the following function, which takes two parameters, word and n, and prints out that by that many times. Because if you remember from a couple of episodes ago, you can use the exponentiation, not the exponentiation, the multiplication operator, which is the asterisk or the star as it's commonly known, with a string, and it'll, whatever integer you multiply it by, that's the number of times the string will be created. But if you multiply two strings, that doesn't make sense. So that operator is not defined for that. We can use this function to print the first line of the song like this: spam equals spam, repeat spam 4. So I'm just defining this variable and I'm passing in that variable into this function. Repeat is not defined because I didn't run this function, this cell. I'm gonna run this other cell, so spam, 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 spam. To display the first two lines, we can define a new function that uses repeat. So the first two lines are just spam, 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 spam. So it's basically using this function twice with spam, this variable spam, right, which we are not passing into this second function. We're just going to define it in the outer scope. I think they'll talk about scopes either in this chapter or the next one. We'll see. You print first two lines, just print spam, 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 spam. Okay, I'm just going to stop. I'm going to stop saying that. And then the last three lines is repeating spam twice, both, and then lovely spam, wonderful spam. So if you define this function and then you print last three lines, boom. Is it supposed to be in parentheses? Well, that's the string. I don't even care. It's just for demonstration. I'm not gonna go look that up. And then print verse. Finally, we can bring it all together with one function that prints the whole verse. Print verse, first two lines, last three lines, and then we print verse, right? So basically, first two lines calls repeat twice with spam 4, right? And then repeat is basically takes some word and repeats it multiple times, right? That's the variable name, but I could pass it anything. Repetition. If we want to display more than one verse, we can use a for statement. Here's a simple example. For I in range 2, print I. Yeah, the first line is a header that ends with a colon. The second line is the body, which has to be indented. The header starts with the keyword for, a new variable named I, and another keyword in. Okay. So, sorry, I had to take a moment, guys. So we repeat, spam. Anyways, we went through these. There's just functions calling functions. Now we go into loops, essentially. For loops is basically the main way. You can also do while, but it's quite rare to actually use while. I've used it in a few situations, but mostly not. If you want to display more than one verse, we can use a for statement. Here's a simple example. The first line is a header that ends with a colon. The second line is the body, which has to be indented. The header starts with the keyword for, a new variable named I, and another keyword in. It uses the range function to create a sequence of two values, which are 0 and 1. In Python, when we start counting, we usually start from 0. When the for statement runs, it assigns the first value from range to I and then runs the print function in the body, which displays 0. When it gets to the end of the body, it loops back around to the header, which is why the statement is called a loop. The second time through the loop, it assigns the next value from range to I and displays it. Then because that's the last value from the range, the loop ends. Here's how we can use a for loop to print two. So this is a very simple, straightforward statement. Range is essentially I think it's a function that returns a generator. And you can give it whatever range, and if you just do for I in range 2 and it has a couple of other arguments, but that basically means it'll be I will be 0, then I will be 1, and then it will terminate, because Python is 0 indexed. So yeah, that's just a loop. It's pretty simple, just doing the same thing we did earlier with this. So first 0, first 1, we're just doing that twice. Print first I, print first print. You could also do print. Yeah, okay, anyways. I was gonna say you could also just give it the separator or a new line character or something like that, and you could just make it double new lines. But then I have to change that in the print verse function, which is up here somewhere. I don't really care. I wonder if I can command and click that. No. Oh wait, maybe I can. Okay, never mind. So you can put a for loop inside a function. For example, print n verses takes a parameter named n, which has to be an integer and displays the given number of verses. Boom. So basically you can use a loop inside of a function. I think in general, in programming, things are very explicit. So saying something like, hey, a function can take, you can do any code within a function, means you can do anything inside of a function. It just needs to execute code, right? What that code is irrelevant. If you want to, that doesn't make sense, but if you want to define a class inside a function and then return a specific function from that class, which is kind of arbitrary and weird thing to do, and maybe there's a case for where you need like a factory class or something like that, or a factory function or something like that, then you can do that and it's fine, right? It's totally feasible. So and formal languages or programming languages are very explicit like that. So if you say you can do anything, means you can do anything, right? If you can't do this one thing, then you literally, no matter what, cannot do this one thing, whatever, right? If a function always has a return value, it'll always have a return value, right? So even for functions where you don't return anything, like see this doesn't return anything, but I'm just gonna run this and then what's going on here? I'm just gonna hit B and then run print and versus, I'm just gonna give it 1, right? If you see prints none, because the return value of this function is none. It's not returning anything, it's just printing stuff, right? So everything will always have a return value, even if that value is none, right? So, and none, even though it signifies non-existence, which is none or null, whatever you want to call it, and it's just none is the reserved keyword in Python, that still has a value, right? Everything has some value, right? You can't, there's no way, I'm not returning anything by not returning something. Functions always have to return something. If they return none, then the value that they have returned is none. And none means nothing, but it is still something. So that is very confusing and cyclical logic, and that's very difficult for people to pick up on. I've learned recently. So yeah, that's an important skill to practice, is practicing that abstract and cyclical logic. Anyways, in this example, we don't use I in the body of the loop, but there has to be a variable name in the header anyway. Variables and parameters are local. When you create a variable inside a function, it is local, which means that it only exists inside the function. For example, the following function takes two arguments, concatenates them, and prints the result twice. Cat twice, part 1, part 2. What is this doing? Part 1, part 2, print twice, cat. Where the hell is print twice? I think I have a function called print. No, I have print verse. I don't have print twice. Oh wait, no, I do. It's right here. So it just prints the string twice, or whatever you give it. So variables and parameters are local. When you create a variable inside a function, it is local, which just means that it only exists inside the function. For example, the following function takes two arguments, concatenates them, and prints the result twice. I'm just gonna pause this. Anyways, so basically this takes two strings or two parts of two anything, right? Though the plus operator will only be defined for certain types. Add them up and then pass it over to print twice, and that's about that. Here's an example that uses it. Line 1, line 2. Always look on the bright side of life. Cat twice, line 1, line 2, which basically just prints that twice. Takes the two strings, concatenates them, and prints them twice. As simple as that. Right? But if I try to print cat, right, which doesn't exist in the global scope, right? It's only in the local scope of this function. You're gonna have an error, name error specifically. So yeah, there's scopes in this, right? We've touched on the concept of scopes here, and we're just talking about local scopes within functions, but that's true of everything, right? Everything has a scope. A function has a scope, a class has a scope. Does this class, like if you have some like math.py, right? It doesn't exist in the global scope unless you import the math module, right? So yeah, everything has a scope basically. And whether or not something is available in the current scope defines whether or not you can work with it. Whether you are trying to execute a statement or evaluate an expression is irrelevant if it doesn't exist in your scope. Side of the function cat is not defined. Parameters are also local. For example, outside cat twice, there's no such thing as part 1 or part 2. Yeah, that's also true. So, if you do part 1, it's going to be the same, right? Just showing that. Stack diagrams to keep track of which variables. I'm just gonna run both of these. It's probably some sort of diagram to keep track of which variables can be used where. Sometimes useful to draw a stack diagram. Like state diagrams, stack diagrams show the value of each variable, but they also show the function each variable belongs to. Each function is represented by a frame. A frame is a box with the name of a function on the outside and the parameters and local variables of the function on the inside. Here's the stack diagram for the previous example. Right, so dunder main, line 1, line 2. These are the variables. Cat twice has these locals, part 1, part 2 cat. Print twice has this local string, always look on the bright side. And then print, always look on the bright side of life. That is not print twice. Oh, I think this goes into the print function, the actual final functions. This is like the entire stack. The frames are arranged in a stack that indicates which function called which and so on. Reading from the bottom, print was called by print twice, which was called by cat twice, which was called by a dunder main, which is a special name for the topmost frame. When you create a variable outside of any function, it belongs to __main. There you go. So everything is in the scope of main, right? um, everything that you write, right? For something to be in the scope of main that you didn't write, you need to import it or something like that, or it's a part of like the base Python language and not part of the standard library provided. Tracebacks. When a runtime error occurs in a function, Python displays the name of the function that was running, the name of the function that has called it, and so on up the stack. To see an example, I'll define a version of printwise that contains an error. It tries to print cat, which is a local variable in another function, and obviously that's gonna cause an issue. To provide detailed debugging information, or including a traceback. Okay. So now it tells you %x mode verbose. Should it be like this? Yeah, okay. Never mind. So there's a name error because essentially this is using a variable that just doesn't exist in the scope of this function. It exists in the scope of another function, right? And so you get a name error. That's basically all that is. And it includes a traceback. The error message includes a traceback, so the stack trace or whatever you want to call it, which shows the function that was running when the error occurred, the function that called it, and so on. In this example, it shows that cat twice called print twice, and the error occurred in a print twice. The order of the functions in the traceback is the same as the order of the frames in the stack diagram. The function that was running is at the bottom. Anyways, why functions? May not be clear yet why it's worth the trouble to divide a program into functions. There are several reasons. Creating a new function gives you opportunity to name a group of statements, which makes your program easier to read and debug. Functions can make a program smaller by eliminating repetitive code. Later, if you make a change, you only have to make it in one place. Dividing a long program into functions allows you to debug the parts one at a time and then assemble them into a working whole. Well-designed functions are often useful for many programs. Once you write and debug one, you can reuse it. These are all true reasons. And functions are not the only construct. There's classes and inheritance and all kinds of jazz. Debugging can be frustrating, but it's also challenging, interesting, and sometimes even fun. And in some ways, debugging is like you are given clues. You have to infer events that led you to the results you see. Debugging is also like an experimental science. Once you have an idea of what is going wrong, you modify your program and try again. If your hypothesis was correct, you can predict the result of the function. You can predict the result of the modification, and you take a step closer to working program. If your hypothesis was wrong, you have to come up with a new one. For some people, programming and debugging are the same thing. That is, programming is the process of gradually debugging a program until it does what you want. The idea is that you should start with a working program and make small modifications, debugging them as you go. If you find yourself spending a lot of time debugging, that is often a sign that you're writing too much code before you start tests. If you take smaller steps, you might find that you can move faster. That is actually true. But also, like at the same time, there are some things that you can just know and do. I've done that. So here's the glossary for this one. I'm not going to go through it, but it's really nice. It's really nice. Exercises. Let's see if there's any exercises worth saying. Ask your favorite VA to write a function called repeat that takes a string and an integer and prints the string the given number of times. Okay, that's a very arbitrary thing. I'm not going to do that. If the results uses a for loop, you could ask, can you do it without a for loop? Okay. Pick any other function in this chapter and ask a VA to write it. The challenge is to describe the function precisely enough to get what you want. Use the vocabulary you have learned so far in the book. Are also pretty good at debugging functions. What's wrong with this version of print twice? Yeah, I am not a huge fan of this. I feel like LLMs for learning can work, but LLMs can't really help someone who's really at zero. If you're at zero and trying to learn something new, like they're there's a part of it where AI overviews of Google or like ChatGPT can be a little bit helpful, but it can also lead you down dangerous, destructive paths where you don't understand something and you just keep prompting to try and understand it. But what you don't realize is you just need to break the loop of prompting and go look it up like from the actual source yourself, because the LLM is just talking nonsense, because it does. And if you're not practiced enough to understand when things are going off the rails, or you're not like actually reading or consuming something that is of value, then yeah. um, Exercise. Write a function named printWrite that takes a string named text as a parameter and prints the string with enough leading spaces that the last letter of the string is in the 40th column of the display. I don't know what that means. Write a function named printWrite and prints a string with enough leading spaces is in the 40th column of the display. Okay, that's a fairly, so you just basically check the length of string, and based on that you add as many new line characters at the beginning. It's pretty simple. Hint: use the len function, string concatenation operator, and the string repetition operator. Here's an example that shows you how it should work. Monty Python's Flying Circus, and it'll just show up on the right. Write a function called triangle that takes a string and an integer and draws a pyramid with the given height, made up using copies of the string. Here's an example of a pyramid with 5 levels using the string L. That takes a string and an integer and draws a pyramid with the given height, made up using copies of the string. Here's an example of a pyramid with 5 levels using the string L. Okay. Called triangle that takes a string and an integer and draws a pyramid with the given height, made up using copies of the string. Here's an example of a pyramid with 5 levels using the string L. Okay, so I think this is essentially just print the same thing again and again. So for the first level, it'll be like space space, string space space, or tab tab, something like that. And you can just repeat that again and again. Write a function called a rectangle that takes a string and 2 integers and draws a rectangle with the given width and height, made up using copies of the string. Here's an example of a rectangle with width 5 and height 4, made up of the string H. Okay. This song, 99 Bottles of Beer, starts with the verse, then the second verse is the same, except that it starts with 98 bottles and ends when the song continues for a very long time until there are 0 bottles of beer. Write a function called BottleVerse that takes, okay, I'm not doing this. I'm definitely not doing this. If you want to print the whole song, you can use this for loop, which counts down from 99 to 1. You don't have to completely understand this example. We'll learn more about for loops and the range function later. Okay, so I'm not going to do any of these exercises, though some of these are good. If you are a beginner, definitely do all these. I am not a huge fan of the ask a virtual assistant thing, even though I was doing that a lot. And like, it's fine to do it, but be really careful, because if you don't know, then you don't know when it's telling you nonsense, right? And that's really the problem with this. Anyways, thank you guys for showing up. I think that's the end of this video, and I'm gonna start recording the next one shortly, but you will see it in 24 hours from whenever you see this one. Take care. Bye-bye.